Hi folks, and welcome to the Ioko Data Science introductory video for the video blog series that we're going to be doing. My name's Tristan Berg. I'm data scientist here at Ioko, and this presentation is just going to be a quick overview of the Ioko data science practice, our headspace as it were, some of the things we're going to look at delivering, some of the ways we think about things, and some of the deliverables that we end up delivering to clients. As I said, I'm Tristan Berg, a data scientist. I studied aeronautical engineering, graduated in 1994, and I've subsequently got some skills doing digital signal processing and some very interesting engineering systems models. And after that, I embarked upon a career of enterprise software, middleware, and cloud architecture. And I've just recently got my AWS certification as a machine learning specialist. So I've been doing data science since roughly 2014, 2015, and here's a video link which you can click on in the links below the video, and that's me speaking all about predictive analytics, in particular at the Mammoth BI conference at the International Convention Centre in Cape Town in 2014. And my LinkedIn profile is also here, so you're welcome to reach out, connect, ask questions, and collaborate with me on being data scientists and doing data science. So an overview of the Ioko data science process and setup is that we design valuable operational processes. And by this I mean we take or look at or work with organizations, and we set up designs for value in operational processes. So we're not necessarily creating things from scratch, but what we are doing is optimizing existing operations and adding new ways to handle data and extracting and seeing and processing new insights and decision-making drivers. We do this by creating data strategies. The data strategies typically involve casting around inside organizations for the data sets that would work for them, which are the data sets that would assist, what kind of information do they have inside the business, and it typically already exists. All the businesses generate data as they run their processes. And how do we curate these data sets and knit them together and weave them into decision-making processes? To do this, we build pipelines, typically software-based pipelines. There are a number of technologies for doing this. I'll get into that in a couple of later slides. Big steps are to pre-process the data. So typically the data will be dirty. It will have missing data. It will have incorrectly formatted data sets or columns in a data set. It may have strings which need converting to numbers. It may have categories that we need to handle appropriately. The pre-processing of the data also looks very, very carefully at data bias. And this is a big aspect of the ethics-first data process and data science process. So, for example, we explore our sampling errors and sample bias. We also look for representational bias. So is the population that we're exploring and looking at, how have they been selected by the business? And what did the business do subsequent to obtaining their data? How did the business handle their processes? And how is that business process either masking or even excluding certain people from data sets? Also, the pre-processing, for example, in deep learning requires that we encode and set up the data for processing by algorithms, software models. So, for example, in deep learning, you have to set up your input matrices or input data sets to be the right size for your layers and also to be the right format for what the layers are expecting. Then we find the best models, and there's an awful lot of information out there on how to do this. The typical processes involve things like running AutoML, automatic machine learning. You can also run algorithms that do a kind of a grid search for models. So we move then into hyperparameter tuning and ways in which we can find the best models for a particular loss function, or for a particular scoring mode. So do we want the best log loss? Do we want to look at accuracy? Do we want to look at the area under the curve of the receiver operating characteristic curve? All these funky terms. But what we're doing is we're finding the best model for this particular data set. Some of the models work better than others. There's a huge number of varying models or machine learning algorithms that can explore your data and find patterns and do a job of predicting out of them. After we've done that, and also in parallel with the whole data strategy, is to build the optimization algorithms. So, for example, which for a manufacturer, given a certain cost function, given a certain income function, and given a certain manufacturing speed function and so on, how do we combine all these algorithms or formulas in using techniques like linear or non-linear programming? How do we optimize the number of widgets to produce? Or how do we optimize the profitability of a particular campaign? And we'll talk about that as well in subsequent slides. Deployment of the pipelines and also the decision engines that can handle all of these various rules, all the various models, all the various processes that typically need to be combined to do something realistic and valuable. These are our deployment concerns. And once we've deployed, we need to manage, monitor, and choose which campaigns we want to either continue with, optimize, or bring to an end. So the campaign management part is also quite important. And remember, most of these things are to do with the real-world implications of our work. Right the way through from the real data that real people and real business processes and real entities in the real physical world are generating, all the way through to what are the campaigns that we want to run and how are we changing and shaping the world in which we're doing business or in which we're running our organization. And then the continuous improvement of these processes as we go on. So our management might show us that our data sets are no longer relevant. COVID-19 is a classic example where a very large shock to many processes has absolutely changed the ways in which these processes run and also the relevance of the data. So how do we enhance our processes and how do we make them robust to these changes? That's under the continuous improvement and enhancement aspects. So a little bit more detail here on what the business impacts are of what we do. When we're running a business campaign, we typically want to maximize for profit or minimize risk, or a combination of the two. There may be other more specific optimizations that we want to run, which is a partial fit. For example, I mentioned earlier, how many widgets should I manufacture if I have a particular demand function? So that's certainly something that the campaign would want to look at and move towards. We want the business is essentially looking for advantage. Another factor might be improving market share at the expense of profit and while being relatively accepting of certain risks. So business risks like expenditures or blanket messaging or the removal of certain other campaigns and so on. So some of the things we can do are things like action choice ranking. Which product is someone most happy to see on their recommendation feed? Which sales message would be best for a particular group? What are the best operational decisions for me along my manufacturing production line? Or if I'm managing a fleet of trucks or a fleet of generators or a fleet of water pumps, when should I maintain them? What does it look like if a water pump is about to fail? How much warning do I get? These are the kinds of things that we want to look at when we do predictive analytics and data science and prescriptive analytics in our data science. Some of the outcomes we can predict are things like customer churn or lapse, for example, of an insurance policy. What would a delay mean? How do we predict a delay, for example, in a delivery? What about forecasting things like number of callers in a call center? So how would we, for example, minimize a costly operational event like a call center being overwhelmed by a very effective marketing message, causing all sorts of folks to phone into the call center? So how would that look, and what would our business models do? Recommenders for example, would recommend either a product once a certain product has been added to a wish list or actually purchased. And how would we improve that? A great example is in one of the business campaigns a while back, touted in a lot of the literature, is folks who had just bought a house were very, very likely to buy a car, or vice versa. Folks who just bought a car were very much more likely then to start spending money on a house. Can we find these? Do we need to know about them, or can our machine learning models pick those up intrinsically? Things like product propensity. So let's say a customer has a particular subscription. Do we want to then promote a more expensive subscription to them, or possibly a lowered subscription? Even though the lowered subscription might generate less revenue for us, maybe our models are telling us that much, much happier customers tend to be linked to the certain products. So maybe a business campaign is out to maximize customer experience satisfaction levels rather than profit. Though I can't see that happening. Many businesses do want to go for the long game like that. Decision engineering is really, really important, and it often doesn't involve a model that we've generated using machine learning. For example, straight rules. Don't sell an exercise bicycle to someone over 65, because in our records we're seeing that 0 people have purchased an exercise bike if they are aged 65 or over. That might be a good idea, perhaps not. What if there's a really interesting group of customers that we're missing? Would that rule then block them? What is our model saying? What is our representation bias and our input data saying? Have we missed people? So decision engineering covers pretty much the entire span of the data science pipeline, and that's why I've mentioned it here in a reasonably clear place. Decision engineering is a big deal. With optimized decision making, we often want to run the optimization engines frequently, and in fact probably on a regular cycle, possibly hourly, possibly weekly, possibly daily. It depends on the business. But these these optimizations will drive decisions, and going into a decision engine, we would then see things like, for example, we're looking at a reduction in stock levels of a particular product, or the optimization has taken into account the fact that we're moving to a space where certain sales are not profitable, so we'll slowly stop promoting that kind of sale effort and rather promote things that are more profitable or less risky. We're looking at multiple and integrated pipelines for decision engineering. A classic example here is we can build a whole pipeline to identify and rank leads that would be really effective to sell to based on certain products. But by the same token, each product itself might have issues. So for example, how do we handle a client who we know will purchase an insurance policy, but then also has a high likelihood to let it lapse before we've broken even? So one of the things we would do there for the business is make sure that we don't promote to folks who have a high likelihood to lapse on their insurance policies. Again, making sure that we've looked at the business's goals in terms of representation, the business's goals in terms of market share, and so on. And then forecasts and alerts can be very, very helpful. Again, the call center model. Call centers tend to follow reasonably predictable patterns, but how do we handle spikes? Would a forecaster or an alert help us there? Is there time after we see an alert of a real spike in call center inbound volumes to scale up, reallocate call center agents, or even send an alert to a management dashboard so that the people monitoring business operations can check to see what the source of these call spikes is? So not only are we putting in optimizers, we also want things like guardrails in our decision engineering. And then the ongoing management is crucial. Data will ebb and flow as our business proceeds and runs its processes. Sometimes, as in COVID, which is an extreme example, a huge number of people's economic activity might change, and that would then make not only our past models superfluous or even irrelevant, it would make the incoming data almost completely different. So we would want to now run a data model model refresh. But remember, if we only have a week's history, how are our models that rely very, very heavily on a year's worth of history going to predict? They're not. So not only do we want to have automated alerts for new conditions and new data sets, but we want to make sure that we're refreshing our models timelessly, tuning them appropriately, and then we're looking at new combinations for improved decisions, especially in light of new business conditions. Right. Just a bit more detail here in the data strategy. So as I've mentioned before, bias is quite key. So in Ethics First AI, one of the things I'm finding is not only do our models work on current data sets, but these kinds of questions help the business ask better questions about gathering their data and how to cast the net wider for their clients. So often when marketers are looking at improving market share, who are the underserved clients in their business? Who is not appearing in their data sets? And is it an intrinsic causality, or is it the fact that we just have set up guardrails that have caused the representational bias? A classic here, for example, is here in South Africa, pre-1994, people of color were prevented by law from owning land. Now, how is that going to reflect on the generational wealth of our current customer base and folks who haven't had an opportunity to take advantage of an inheritance and so have not really owned property? So now all of our data sets talking about whether or not someone is going to pay back a home loan are going to be missing the majority of our financially active people in the country. And that's a serious, serious problem when we want to do predictions. Not only are we not being ethical by only granting home loans to folks in our current data sets, we're being unethical in we're being unprofitable in terms of approaching our current marketing conditions and looking for models that actually really can predict real payment behaviors. So it's a massive challenge in the industry, and it's something I'm personally very passionate about and engaged in. There are a number of ways to change these things, and one of the ways possibly might be to divert marketing spend into running pilot programs with clients, choosing an hypothesis on whether or not folks may pay back, or just choosing an optimal data gathering and scientific method approach, and also being statistically rigorous in how we look at gathering our info, and then working much more closely with the communities who we impact in improving the ways in which we run our predictive analytics. So pre-processing, type checks, cleaning imputation, I mentioned these. Target imbalance is a big one. For example, in fraud or anomaly detection, less than 1% of the actual data items may contain your target variable. And this is an extreme imbalance that requires very careful checks and balances and approaches to modeling. Feature engineering is a big one. It's one of the ways to get extra information out of data sets that the algorithms themselves necessarily won't find. A classic example there is, for example, taking the time delta between a booking of a holiday and the actual date of the holiday. When working on some Kaggle competition information, I found that I'd managed to get quite a good accuracy just by doing that little feature engineering trick. And there are many more of those, and often they can be automated. So that's quite interesting. Round trip engineering is an interesting one. Once we have the closed loop mechanics of our pipeline set up, we can watch as various data sets change our model output and accuracy. We can see the impacts of various choices we've made in the design, and we can look at how, for example, we deploy a big pipeline, we've optimized, and then we apply the business rules, and suddenly, instead of us having 10,000 leads to hand to the marketing department for their campaign, we have 100. So obviously some of the rules are showing us maybe we've got something wrong, or what we should do is back out of certain rules and revert to different campaign strategies. Model discovery, model performance validation, which is the best model. These are all aspects of deeper detail that we can run in data science. And model discovery and selection is often automatable, but sometimes does require the practitioner to have a look. So tuning and ensembling are interesting ones there. Ensembling, certainly. There are a few of the more sophisticated vendor packages like Data Robot or H2O AI driverless that are quite expensive, but they do a very good job of automatically taking numbers of good candidate models and ensembling them for your outputs. It's a very interesting approach because it gives a very robust, highly calibrated output, and model calibration is something we really want. So that's also the subject for another presentation further down the line. So model performance validation is important. We need to make sure that our model works on holdout sets, and this includes out-of-time checks. For example, if you're running an out-of-time check where you build the model on data from a month ago and you test whether it could predict really well a month ahead, that would mean you're up to date on building your model, and COVID hits. What would happen there is you'd see very quickly that COVID would show a month ahead performance which would be dismal, and you'd pull the model out of production in time. Pipeline validation on a subset of live pipeline data is crucial. What would happen there is that protects us from an unseen bug or an internal error where we missed, for example, that the model wasn't performing well on a particular subset of data, or it wasn't performing well at all, but by some fluke we'd managed to get a good holdout data set, and this happens. So what would happen with that is we deploy the model for real on 20% of the customers and leave the other 80% of the customers running business as usual as a control. And if our 20% of the live pipeline customers actually performed worse, we'd know not to deploy to full coverage, that is, all the customers. And what would happen there is we could then go back and find out and debug what went wrong. Possibly we switched a rule, possibly a rule that was needed wasn't put in place, and so on. The optimization algorithms come into play at this point and are also integrated into the decision engineering. And as I've said, they're things like how many widgets should you manufacture. They're also things like based on my rankings of which customers are likely to churn, how many messages should I send out if messages cost me £1 a message or $10 a message, whatever the case may be. And these are also then, as I say, deployed to the decision rules engine. And then another point here is the outcomes monitoring. It's crucial that we close the loop. By closed loop, I mean the effects of what our model is doing are fed back into our ingested data, and we then watch as our models interact with the new data coming from our customer group. And what happens there is we'll be able to see model drift, which is where we set a model accuracy level, and some of the inbound data is used as a holdout, and we check the model against the new data. And if the model's accuracy starts to drop below a certain threshold, we know it needs to be retrained, and or we need to take a look at the input data. And it's very important here that we keep our pre-deployment baselines. And the pre-deployment baseline is the baseline of the information of outcomes. So, for example, what kind of sales we'll be making, what were our profits pre-deployment of our models, how much did it cost us to send out an advertising campaign, and how many leads did they generate? What influence and impact has our model had? And those baselines are crucial. Those are part of the data gathering and data strategy phase, really, and typically tend to be accounting and management accounting metrics. So here we have a view of a bit more information on the resources and technologies that we use here in Ioko for our big data, our data science, our prescriptive analytics and optimization efforts. So the top row just shows us to do with what's going on at the client. So for example, we've got measurements and data coming in, and in the cloud we have the Ioko cloud, the AWS cloud, Google cloud, and Azure and IBM. We're capable of working with pretty much any large-scale hybrid or cloud data architecture, and this includes all the way through from sophisticated data virtualization using vendor packages through to end-to-end almost mainframe to mobile integration, where all the various data formats, data flows, the various data types and locations are all integrated to give businesses the ability to integrate all of the data that they're busy running in their organization. And then we can generate our artificial intelligence, machine learning, and prescriptive analytics outputs based on this cross-cutting view of businesses. Some of the aspects of the modern data science landscape are things like IoT sensors, www, the World Wide Web. We can crawl vast amounts of information now. The entire Wikipedia can be used, for example, to train a natural language processing model. We can do social listening with some very sophisticated techniques, one of them being crowdsourcing, where people actually read tweets or Instagram posts or Facebook manifestos and come back to us with things like sentiment or intentionality or whether it was a complaint or a compliment and so on. And also the advent of new connectivity and bandwidth technologies like 5G excuse me, are really helping out with giving us the ability to put amazing information at the edge of the digital platforms we do our business on. Ioko streaming is available, so we're starting to look at things like Spark and Spark streaming for moving data quickly and working with event-based architectures. Again, this is an overview. These will be covered in subsequent videos. AWS and GCP runs what they call the IoT Core or IoT-Core. Azure has their IoT, and IBM Watson IoT is IBM's offering in this case. And I've highlighted here things like IoT, but that goes hand in glove with the data virtualization, the data lake, the hybrid data architectures, the edge architectures, the relational databases that I've already mentioned in the row above. Within Ioko, we have the Ioko Data Fabric, which is a loosely federated group of products and technologies that we integrate. We then have AWS, Google Cloud, and Azure Data Lakes, as well as IBM Cloud Storage. And taken together, these give most of modern organizations a real advantage in terms of getting their hands dirty, getting their best leverage from their data sets. And then we use that through to do our deep learning, our machine vision, natural language processing, as I've mentioned. Shallow learning, which is just a silly way of saying general machine learning that isn't deep learning. And then, of course, the Ioko optimizers, which I've talked about, which is the group of formulas and equations and algorithms that we build up for a particular business to do with the best ways to make decisions in their businesses. And the decision engines are typically things like rules engines. So we have the Red Hat Decision Manager, which IBM sells. We have the open source rules engine. We have IBM iLog. And then within the cloud providers, there's all sorts of information that we can build up, all sorts of structures and architectures that we can deploy in the cloud. And of course, to tie it all up and to give us a feeling of a view of everything that's going on under the hood, the dashboard. And Ioko has a dashboard set up where we can integrate numerous views, both static and dynamic, of what's going on in the business. AWS, Google, Azure, and IBM all have their own offerings, and Ioko works with and delivers on all of those. And right, so we come pretty much to the end of this initial vlog. This is the Ioko homepage, and I invite you to make contact with us there. You can also email me. I'm on LinkedIn, as I said. You can also email me. That's tristan.berg@ioko.tech, and get in touch. We have numerous marketing and business integration folks who would be very, very happy to assist you, and you're more than welcome to bother us. And we look forward to doing business with you at some point in the future.